Hi there. I'm going to attempt the sign and cos challenge, which is recommended in your week 3 of design programming. Um, it will explain you on how to use sign and cos and how we can take the output of sign and cos and map it to different values to do something in a cyclic manner. Um, so yeah, let's get started with it. So as you can see here, it says that sine and cos gives you a value between -1 and 1, which, and it keeps on repeating, right? So that gives us an idea of how you can actually just supply a value to sine or cos functions and get a value back and repeat something. So we're going to use that fact to create a sketch similar to this one. Again, I'm going to say that you don't have to recreate it exactly, but as close as possible should be fine. And what is more important is that you understand the concept. All right, so we have the code here. It has some help functions. So the first thing it says is write a for loop to get the x coordinates of each ellipse. So I'm gonna just write for let I equal to 0, I less than, just gonna go with 20 because I want 20 circles, I plus plus, and then I'm gonna map this I from 0 to width minus radius to be able to get the x position. So map I, which we know x is from 0 to 20, map it between width minus radius. So I have the x pos now. What I want now is the y pos, which is something which I'm going to get from the cos or sine function. So I'm going to first get the sine val, which is going to be sine of angle, and then I'm going to map this value to y pos. So we know that sine val is the value which exists between -1 and 1, and I probably just want to keep it between 1/4 of the height and 3/4 of the height, right? So I'm going to write height by 4 and 3 star height by 4. With that, I'm just going to plot the ellipse on the screen. Ellipse, x pos, y pos, and the radius. We already have the radius up top in the code. So radius and semicolon. Oops. Let's just run this and see what the output is. We can see that all the circles are just bouncing from bottom to top, and that is not something that we want. So what we're going to do is actually change the angles applied to each one of them slightly. Just to try, I'm going to just apply I, because I is going to be different for each one of them. And if I run this, you can see that each of the circles are just bouncing in a different rhythm. And that pretty much completes this first step, because we understood how sine and cos work. We don't necessarily need to have something this close, but if you want something this close, you would want to maybe increase the number of circles. So let me just create a let num circle here is equal to 25 and use num circle here, and num circle -1 gives me the same output. I could try multiplying this. So what you want to do is keep the angle between two consecutive circles really small. So I could just maybe divide it by I and see how it goes. But it's somewhat like that. I could multiply it and see how it does. It doesn't matter as long as you're able to understand the concept behind. Whoa, that's too fast. I don't want that. So it has to be a significant amount of increment, I suppose. Let me try that. But yep, that's easier to see and understand. So you can play around with the values and see how it goes. You can even change the angle value and see how it performs. That's way too fast. But yeah, you get the gist of it, and that is pretty much it for the first step. We'll move on to the next one for now. Feel free to play around with this one, pause the video and have a look at the code. Now the second one talks about, actually looks like this, where a circle is actually going around the mouse pointer in a circle, and it's changing its shape based on the position of the mouse and the speed as well. So an important thing to understand here is that math can play an important role in creating your designs. So over here, in specifically in this challenge, or this step of the challenge, we're going to use this special equation of a circle where the x and y coordinates are defined by the angle passed to cos and sine, and then that is multiplied by the radius of a circle. So this will form the the outer circle in which the inner circle is actually going around. So we are going to do that for sure. And this is, I believe, is called the angular equation. Not super sure about what it's called, but yeah, it does that. So just to start with, we are gonna declare an outer radius of sorts for the circle, and let's say we call it outer radius as 50. So that is the outer one, not the inner one. The inner one is we're gonna use it as radius. So maybe just for clarity's sake, I'll rename it to inner radius. All right. So the x coordinate now would be, as the equation above the code block says, outer radius multiplied by cos of angle, right? And similarly, the inner radius, sorry, the y coordinate would be outer radius multiplied by sine of the angle. And I think I'm just going to ignore this line for now. With this, we have the x and y point of the outer circle, where I'm going to draw in the inner circle, and the radius would now be called inner radius because this is for the ellipse which we are actually drawing, right? Let me just run this and see how it looks. Doesn't look too good. Oh wait, I wrote sing instead of sine. Right, so you can see it's rotating somewhere on the corner, but it's not following the mouse or anything, right? That is because it's x and y and not something else. So what I want to do is make sure that it rotates around the mouse, which means I want the center of the outer circle to be mouse x, mouse y, and I'm going to wrap this in brackets, and y would be mouse y plus whatever. Now this equation will take care of keeping it around the mouse itself. You don't have to worry about subtracting or adding or whatever, because remember, cos and sine give you negative values as well, right? So it will automatically take care of moving it around. So let's try and run that, and the circle is now moving around at a very slow pace, which is fine. Now in order to change the size, we want to modify the inner radius, right? And to do that, what we'll do is I'm probably just going to copy that from here to here, and just click the format button so it looks nice. And let's map the inner radius based on mouse x position. You can use anything, but I'm going to use mouse x position. So I want mouse x when it's between 0 and width. I want a minimum size of 10 and the maximum size of, let's say, 50, right? And this will define the size of the circle that is rotating. So if you go towards the left, the circle is smaller, but if you go towards the right, the circle increases in size. Now the next thing I want to do is change the angle, the speed of which it's rotating based on mouse y position. So if I go up, it'll go slower. If I go down, it'll go faster. It might be a little different in the animation below. I think it's the opposite, where the size of the circle is actually changing with mouse y and the speed of the circle is actually just changing because of mouse x, but you can just always interchange that, and that should not be a problem. So I'm going to declare a new value here, which is called delta angle. This is the change I want to introduce in the angle as the mouse moves around. I'm going to map my mouse Y, which is between 0 and height, to be between, let's say, 0.05, which is extremely slow, to 0.5, which should be massively fast. And I'm just going to use delta angle as the change here. Oops. Yeah. Let's run and see how this performs. So 0.05, as we have already seen, is quite slow. And as I go down, it should go faster. There you go. So it's spinning quite fast. And as I go towards the right, it actually just goes faster and bigger at the same time. In order to make it very similar to what is happening here, just change this to mouse Y and change this to height. Change this to mouse X. So instead of mapping across and down, we're now mapping down and across for inner radius and delta angle respectively. This will be width. Maybe I want to make it go a little faster, and let's see how it goes. There you go. It's going super fast. And that is slow and small and fast and big and slow and big and fast and big. So yeah, that completes the solution for this second part. Definitely give this a try and ask any of the tutors on Slack if you have any questions. And there's handy documentation for sine x, sine, cos, mouse x, frame count, and everything. We haven't used frame count, but it might be useful if you want to change the angle based on frame count itself. So yeah, that was it, and hope this was helpful. Thank you.